Okay, let us discuss now the sixth unit topic, Introduction to Graphics Processing Unit. That graphics processing unit is popularly known as GPU. So GPU is a common terminology now used uh, for the graphics processing unit. Many of the laptops, desktops, or the workstation, they come with this particular additional processor, that is graphics processing unit. But particularly many of the computers, they have the NVIDIA GPU, which is one of the popular GPU. So uh, in this particular topic, we shall be studying the characteristics of this graphics processing unit, which contains the which uses highly parallel processing unit. So we shall see first the introduction, then the characteristics, and in brief we shall see at the end the architecture of the NVIDIA GPU. So as the Moore's law says that with the advent of the technology, the uh, the number of transistors in a particular device, they are going to increase, and okay, there was an interruption. Am I audible?
Yes, sir.
Okay. Still some students are coming. Let me switch to the screen. Okay, so as per the Murray's law, if you look into the Murray's law, then it tells that how fast or it predicts how fast the number of transistors in a particular single device or single chip are going to uh, increase. So today also it is more or less applicable, and because of this we can see that day by day the advanced processors are coming, and all these particular processors, they are integrating the large number of transistors into it. So the CPU, because it works, or it one of the major peripheral with the CPU is the display. Uh, so the advancement in the display happened, and from the text display, the graphical display came, and then that particular graphical display, it went from 2D to 3D, and now the special controllers were being used for the purpose of displaying the screen. Okay. The major driving force for improving the graphics processing, it was the computer game industry. So if you look into the requirement of the graphics, then for the normal applications, the graphics or the screen don't need to change much for the regular applications. But if you look into the gaming applications, then in that case, the gaming application demand uh, very frequent change uh, in the screen. Okay, so as you play certain games, in that case the high level of graphics is required, and that particular graphics is, or whatever graphics is going to be displayed, so that is in response to the user action. So if the user is moving the mouse or some with the joysticks, certain controls, left or right or up down, like that, arrow keys or the joystick keys or lever, then in response to that particular gaming application need to respond and display immediately the appropriate screen. So the purpose or the main driving force for improving this particular uh, uh, graphics processing unit, it was the gaming industry, and there are very much popular games, and there is lot of investment, and there is lot of money that is being earned out of this particular gaming applications all over the world. So the for giving that particular effect, the GPUs were developed to support the required graphics. The graphics processor increased in power. They earned the name Graphics Processing Unit, or GPU, to distinguish themselves from the CPU. So there are certain operations which are uh, like specific to the display of information on the screen. So such operations were confined to a particular processor, and that particular processor was known to be the graphics processing unit. So it would not do any other operations, only operations which are related to the graphics. So your CPU will be relieved from the graphics operation. Otherwise, earlier the CPUs were having special instructions for the purpose of displaying the graphics, but now the CPU will be free from the you can say the displaying the required things on the graphics. So the responsibility of displaying the things on the or the responsibility of the GUI, that is graphical user interface of the computer, it is given to the GPU, that is graphics processing unit, so that the CPU can do its other work. So the GPU and CPU, they work together. So at the time when certain graphics operations are happening, then at that time the GPU takes on those particular operation, whereas at the time when the normal other operations are there, then at that time the CPU works. So you can say it is the heterogeneous processors, they are working together so as to improve the performance of the computers. So what are the key characteristics of this particular GPU? These GPU are accelerators that supplement a CPU. Okay, so it is the accelerator, the graphics screen. You can say it is accelerated. That is, it is rather fast changed. If CPU would have been used for this particular graphics, then the speed at which the screen changes, the graphical screen changes, would have been much less than what the GPU does. So GPU is, you can say, special processor. It is specialized only for performing the graphical application. Okay, so they do not need to be able to perform all the tasks of the CPU. Okay, so CPU is a general purpose and it performs many tasks, but GPU performs only the tasks related to the graphics display. Okay, so it is supplement to the CPU. Okay, so it is supporting CPU in displaying the graphical screen. So the example is the IBM cell architecture, in which the CPU and GPU, they work together to form a heterogeneous system. The programming interfaces to GPUs, they are the high level application programming interfaces. So these high level application programming interfaces, they are called APIs. Okay. So these particular APIs are available for this particular GPUs. These APIs, they are OpenGL, Mantle, and the Microsoft DirectX. These are some of the examples. There are other APIs also that are available with this, which can be used with this particular GPUs. Okay, so these APIs, they are the programs which are typically written for this particular GPUs, that is graphical processing unit. Like CPU has the program, there are certain programs that are written for CPU that uses the instructions of CPU. For example, it can be 8086 CPU, it can be Pentium CPU, or it can be some other CPU. So the programs for that particular CPU, they are written, but here when it comes to using the graphical display, then in that case you need to use the interfaces. Okay, or interfaces, they are nothing but the services that are being provided by this particular APIs, that is application program interfaces, and this particular program contains the instructions, specialized instructions, which can be understood by this particular GPUs. Then the graphics processing involves drawing vertices of 3D geometry primitives such as lines, triangles, or different polygons, then shading or rendering the pixel fragments of the geometric primitives. Okay, so the basic operations involved in the GPU, it is nothing but the uh, drawing of the graphics. So most of the time, any graphics is developed by drawing the the geometrical, you can say, uh, curves or lines. Okay, so it may be it is starting from the vertices up to the lines or the circles or ellipses, triangles, rectangles, squares, or the multiple dimension polygons. Then after that, it is the shading of certain areas. Okay, so like this are the basic operations, okay, of this particular GPU, and with this particular basic operations, it may draw the complex graphics which can be displayed on the screen. Each vertex can be drawn independently. So GPU is evolved to the GPU is evolved to execute many threads at a time. Okay, so the it is basically uses many threads. So in the last topic, we have seen multi-threading, and these GPUs, they make extensive use of multi-threading. So okay, so unlike the graphical, unlike the CPUs, which has got certain data types, am I audible?
Yes, sir.
Oh, okay. Okay. On my other device, I was getting a signal that I am disconnected, but okay. I think it is all right. So the CPUs has got the data types like the character, integer, then you have the floating point number. In the floating point number, you have single precision, double precision, and strings. That is, you can construct the special data types from this particular basic data types like that. Okay, but when the graphics processing unit works, then basically it works on a data type, and that particular basic data, the graphics data type being the vertices. Okay, so this particular vertices, they consist of four numbers, you can say, or four elements: x, y, z, and w coordinates. So these are the and the pixels. They are consisting of the red, green, blue, and alpha. Okay, so corresponding to every pixel, you have its color, which is identified by the red component of that pixel, green component, and blue component. So how is the mixture of that? Alpha corresponds to the opaqueness of that particular color when you are typically superimposing two different images, then how opaque is one image. So if it is opaqueness, it corresponds to the transparency. Okay, so if it is opaque, you cannot see what is behind that particular image. But if that part of the image is transparent, if it is fully transparent, it will be like a glass, and you will not be able to see the upper image, and it will be the lower image you will be seen. But if it is, let us say, 50% transparent, then you will be able to see the 50% part of the upper image, and through that you will be able to see the remaining part. Okay, so the opaqueness is the degree of opaqueness is shown with this alpha, and along with this, of course, the coordinates. Typically in two-dimensional, it will be xy coordinate, whereas in the three-dimension, it will be the three coordinates where that particular pixel is to be drawn. Okay, so whether you are using 2D graphics or 3D graphics, based on that. The working set can be hundreds of megabyte. Okay, so there will be large number of such collection of pixels, and the GPU is working at a time with this megabytes of data, and each byte corresponds to a part of a particular pixel. Okay, so typically a pixel is formed with 4 bytes typically. Okay, or 8 bytes, and like that, depends on how is the structure for that particular for a particular pixel that is used in a GPU. It does not show same temporal locality as data does in the mainstream application. Okay, so if you compare the applications of the CPU, in which the CPU is going to again and again work with the data which is in the vicinity with each other. Okay, so it is working with the same data, and usually that particular data we keep in the registers, and we process that particular data. Okay, so the CPU instructions, when we write certain program, then they typically work with the group with a smaller amount of data, and that particular data we after it is being processed fully, then that is given as the output. But contrary to this, the GPUs, they work with the large amount of data simultaneously. Okay, so the megabytes of data simultaneously. Okay, so as a result of this, because of this particular characteristics, what happens is that CPU uses caches. So because the same data is required again and again, CPU uses the caches. So but GPU, because it works with the large amount of data, and once some data is being processed, then it need not have to process that data, but it need to process the large amount of other data. Okay, so GPU do not rely on multi-level caches, so they do not use the multi-level caches as that of the CPUs. Okay, if multi-level caches are used, then there will be delays and latencies, because you need to copy it from one level to the another level, and like that, so there will be delays. So GPUs do not use the multi-levels of the caches. Okay, whereas GPUs rely having enough threads to hide the latency to the memory, whereas GPU will be having the large number of threads, and this large number of threads, what they do is that they simultaneously read from this particular part of the memory. Okay, uh, so or it reads or it processes, so that there will be no latency, and your graphics display is accelerated. Okay. Then GPU rely on extensive parallelism to obtain high performance. So it uses parallel processing. It implements many parallel processors and many concurrent threads. Okay, Okay, so there are concurrent threads. Concurrent, the meaning of the concurrent, as you know, it is the simultaneous, and threads, it is the flow of execution. So large number of flow of executions are there inside this particular GPU or graphics processing unit. The GPU main memory is thus oriented towards bandwidth rather than latency. Okay. So the processing, the high amount of processing is there in the GPU. So that is why you can say the bandwidth is rather high than the memory. So there are even separate DRAMs chips for the GPU. So the memory used with the graphics processing unit is separate. So you might have heard that with the GPU, the graphics processing unit, they comes with the special graphics RAM. Okay, so that particular RAM is exclusively used by that particular graphics processing unit. So the capacities of this particular display RAM, it may range from 2 GB to 24 GB. Okay, some of the processors you may be using on your laptop may be having only 1 GB of the graphics memory, but it can be, if some silicon graphics workstation is there, then that particular memory, it may be as high as 24 GB. But this particular graphics memory, of course, is less than the main memory that is being used by CPU, and typically that's to nowadays CPUs, they are using the internal memory to be 32 GBs or more than that. Okay, but typically in the laptops today, we have the 4 GB or 8 GB or 16 GB of the memory. So the memory is here. The point is that there is a separate memory for the GPU, and GPU works or reads parallelly through this particular, or you can say there are large number of data streams. There are large number of data streams to read from this particular dynamic memory, which is directly connected to the GPU. Okay, so bandwidth is high, you can say, because of which the large number of data is being read simultaneously from that particular memory. Okay, so given the reliance on many threads to deliver good memory bandwidth, GPU can accommodate many parallel processors as well as many threads. So if because it is supporting many threads, so it has many parallel processors, and these particular processors, these particular threads, they can be assigned to this particular parallel processor, because more or less the graphics which is to be performed, or which is to be executed for a group of fragment, it is same for the all. For one fragment, it is same for the group of fragments. Hence, each GPU processor is highly multi-threaded. Okay, so this particular GPU processors, they are highly multi-threaded. It consists of large number of processors. GPU rely on extensive parallelism to obtain high performance, as already seen, implementing many parallel processors and many concurrent threads. Okay, so this is the summarization of the many earlier points seen. Given the 4-element nature of the graphics data types, so you can have the data types of the graphic data type. Usually it is X, Y, Z, W. So GPU historically have the SIMD instructions. So we have seen the different parallel organizations, and the SIMD, that is single instruction multiple data stream. So such instructions, so such instruction, that is a single instruction is there, which that instruction, it operates on the multiple data. So such kind of instructions can be popularly used with the GPU processors, whereas the GPU processor essentially you can say is its architecture is like SIMD, that is single instruction multiple data streams. So unlike CPUs, there has been no support for double precision floating point arithmetic. Okay, so with the CPUs we have the single precision data type, which is 32-bit in size, whereas there is a double precision data type, which is 64-bit in size. So you have two different precisions for the floating point number, whereas the GPU, it uses a single precision data type. So it is not have it does not use multiple data types. That is that particular GPU is made simple. The operation of the GPU is made simple by having to support only limited number of instructions, and having to support the limited uh, data type, okay, or typically a single data type. Okay. Now, having seen the characteristics, now this is the architecture of a typical GPU, NVIDIA uh, GPU. So it is implemented by NVIDIA, okay, and the processor is GeForce 8800. So you can see that there are large number of uh, uh, the processors in this. Okay, so on the right side you can see here it has got various cores. Okay, so this is one core. So like that, many cores are there, and in this particular cores there are processors. So SP, they are the single processors. Okay, and above and below that are the various blocks which makes use of this particular processors for the purpose of the graphical processing. Okay, then below it there is a DRAM, and there is an interconnection network between these particular processors and this particular DRAM, that is dynamic RAM. Okay, uh, though we have seen that this particular processors do not make use of the caches, okay, multi-level caches, but a small cache is there, which is available with this. Okay, so that the processors will be able to work independently. Okay, so this particular unit so this particular figure shows uh, a GPU with an array of 112 streaming processors. So this SP, they are the streaming processors, uh, organized as 14 multi-threaded streamings. Okay, so this SM, it stands for the multi streaming multiprocessors. Okay, so this particular one core, you can say it is the streaming multiprocessors. Each SP core is highly multi-threaded, managing 96 concurrent threads and their state in the hardware. Okay. The processor connects with 464 wide DRAM partitions. So this particular DRAM partitions, they are 64 bit wide. So the basic data type, it is of 64 bit. Each SM has 8 SP cores, 2 special function unit, SFU. Okay, so you can see here that SFUs are there, and these are the 8 cores in one SM. Okay, so and a multi-threaded instruction unit and the shared memory. Okay, so there is a shared memory over here, so it is being shared by all these particular streaming processors, CSPs. So this is the basic Tesla architecture implemented by the NVIDIA GeForce 8800. Okay, so the purpose of showing this particular architecture is that large number of processors are there in the graphical processing unit. There are large number of processors which are working together, and as a result of this, what we get is this particular the graphical screen. Okay, so we have seen this particular GPU in short. Okay, so we discussed the characteristics of the GPU, and at the end we discuss the GPU architecture of the NVIDIA. Okay, this is the multiprocessor network topologies will be the next topic. Okay, and for this you can refer to the book of the Computer Organization and Design by Patterson. Okay,